Welcome, everybody. So what I'm going to do now is, my name is Susan Ibach. I work for Microsoft as a technical evangelist, and I'm going to give you guys a fun introduction to the world of machine learning. Machine learning is a fascinating area, and I think one of the things that's really interesting about machine learning is for a lot of us in the past, machine learning is nothing new, but I think in the past it's something that seemed only accessible to PhDs and data scientists and people who'd spent grad work studying data science and seemed maybe inaccessible to the rest of us. But there's been sort of a critical movement in the last 3 to 5 years in terms of the data we have available to do machine learning and the tools that are available and the CPU power we have available with things like the cloud, so that it's become a lot more accessible than it was in the past. So what I wanted to do today was teach you how to run some basic experiments using machine learning. The tool I'm going to use is Machine Learning Studio. The principles I'll be showing you can be used in any machine learning tool. And hopefully you'll be able to have some fun with it and explore the world of machine learning. All right, so without further ado, really the reason machine learning is very exciting in the industry, and there's a lot of buzz these days around machine learning. You're seeing startups created off machine learning concepts, and you're also discovering that there are companies and big companies who are trying to use machine learning as well. And really it's all about trying to predict the future, because of course if you're in a company and you can predict the future, you can make more money, you can be better prepared, you can anticipate and take actions to be best prepared and take advantage of your knowledge of the future. And that's what machine learning is really all about. It's about taking historical data to make predictions on what's going to happen down the road. So the most important part is the data in the background. So we have to have past data to identify patterns which we can use to make predictions on what's going to happen in the future. It's a little bit like, I don't know if you remember way back in grade 10 and 11, they probably had you drawing graphs in school, and you were calculating the slope of the graph, and they'd say, hey, if you added this additional point, what would the value be if you added this extra point, and you would have to extrapolate your lines to try and predict what the values would be. Well, that's kind of what machine learning is doing, except it can make some pretty complicated formulas to represent the pattern. So it's a little more complicated than just calculating the slope on a line. But in the end, computers are good at calculations, they're good at formulas, and that's why computers are so great at machine learning. So the tool I'm going to use is called Azure Machine Learning Studio. It's a fun one that lets you explore machine learning without having a degree in statistical analysis. So what I'm going to do here is I'm actually going to launch a browser, and I got lots of windows open, so I got to find the right one. This could be fun. Dum-de-dum-de-dum. There we go. Found it. Dum-de-dum. I want that one that says experiments. Dum-dum. There we go. So this is a tool called Azure Machine Learning Studio. Now, if you want to launch it yourself, all you do is search for Azure Machine Learning Studio. I'm terrible with URLs. I just look things up when I need them. So when I type in Azure Machine Learning Studio, you'll see this URL here, studio.azureml.net. And if you click on that, then it's going to take you to a site. And mine's already signed in, so it's letting me go to my experiments. But if you've never done machine learning before and you want to try it with me, there is actually a guest sign-in you can use. So even if you don't have any cloud credits on Azure, you can still play around and have some fun with the experiments by clicking the guest sign-in, and you get 8 hours worth of free machine learning experiments. If you have Azure accounts, I'll give you links later on how you can get access to Azure and get a more full-featured version, but this still allows you to do a lot of playing and to do a lot of what I'm going to show you here. So that's a useful link for you. So I've already signed in and launched it, and when I go to open up the tool, the first time you open it, you won't see anything listed here. These are some experiments I've run already in the past. Machine learning is really about running different types of experiments, and the experiments allow us to explore and find patterns in data. So I want to create a new experiment. So I select experiments and I say new. And I really like to do my demos with file new project, because that way you really feel like, hey, if I had to do this myself, I could actually reproduce what Susan's doing completely from scratch. There are a number of sample experiments that you can go take a look at here, and you can open those up, but I like starting from an empty experiment so you can really see how we do something from scratch. So we'll pick that blank experiment. And what we need, first of all, is some data, because machine learning is all about looking at past data to try and find patterns to predict the future. So where do we get this data? Well, if you have data of your own, say in something like a CSV file or inside a database that you can extract from a database and then load into a CSV file, there is the ability to actually down here, you could say create a new data set, and then you could actually upload a CSV file and use that data. Another option you might have is there is a task. I'm going to use this search box a lot, by the way. It's really handy for finding the tasks I want to work with. And that allows me to add a reader task. If I drag that over, you'll see that I can use properties to say, go get data from a web URL. So I could use something like an RSS feed, data feed providers, Hive queries for people who are doing things like Hadoop, Azure SQL databases, and so on. So you can read directly from tables. That's a useful feature. But I'm actually going to take advantage of the fact that there is some data built right into this tool, which is great for playing and exploring and learning. And that way I know all of you have access to the same data set and can try it as well. So I'm going to drag over this data set here called Flight On-Time Performance, because this says something about my life. I like this one because I'm going to try and use this data to predict whether the next flight I'm catching is going to be late or on time. The first rule of data science and machine learning is really to spend some time getting to know the data. The data is the biggest part of your work when you're doing machine learning. The more you know, the more data you have, the better format of the data is, the more successful your experiments are going to be. Since we don't know this data, you've never seen it before, there are tools built into this machine learning studio to let you look at the data. So I can right-click on this and say Dataset Visualize. And when I visualize that data, it actually shows me lots of interesting information about this data set. Great when you're using somebody else's data. I can see that I have 500,000 rows of data, 18 columns. I can see that I have data over different years, quarters, month, day of the month, day of the week. So this is all information about different flights. This data actually came from open data from the U.S. Department of Transportation website. So this is actual flight data for different airlines. And the carrier is which airline was making the flight. And you might be wondering, well, is all the data from one airline? Well, if you look over here, when you select an individual column, it actually tells you information about the columns themselves as well. So you can see that there are 16 different values for carrier. And if you scroll down, you'll even see a histogram to give you an idea of how many records there are with each of the different airline values. So you can sort of see that we've got YAA, which is probably American Airlines. I'm going to guess DL is Delta. You'll notice there's no Canadian Airlines. This did come from a U.S. Department of Transportation data set. We have the originating airport ID. So where did the flight leave from? Where did the flight go to? The destination airport. We have scheduled departure time, the hour period during which the flight left, departure delay, how many minutes after scheduled departure time the flight actually left. Whether on this departure delay 15, this is a Boolean flag. It'll be a 1 if a flight left more than 15 minutes late. It'll be a 0 if the flight left on time or less than 15 minutes late. Scheduled arrival time, the scheduled arrival time block, how many minutes late the flight arrived. If it's a negative value, that means the flight actually arrived early. And we also have arrival delay 15, and this is a really important column. This is a column that will be a 1 if a flight arrived more than 15 minutes late. It will be a 0 if the flight was considered on time, so less than 15 minutes late. This is the value I want to actually try to predict. So I want to look at the patterns of past flights that were late and on time to try and predict if future flights will be late or on time. That's what I'm going to try to be doing. It's also a good idea to learn, so you need to sort of learn the columns. You should also click on the different values, columns themselves, and look at some of the information. For example, when you select quarter, you'll actually discover that the number of unique values for quarter is 1. That's a shame, because if you think about it, when I do machine learning, the other thing I have to think about is which of these columns do I think would affect whether a flight is on time or is late? You know, what airline it is. It's possible that American Airlines is on time more often than US Air, or Delta is on time more often than Alaska Airlines. So I think the carrier is a factor I would want to look at when trying to analyze if a flight's going to be on time or late. And the day of the week. I think I might want to consider that as a factor as well, because there's a different pattern. Sort of weekend travelers tend to be more casual travelers on Saturday, Sunday, whereas the business travelers Monday to Friday. So I think the day of week might be a factor in whether or not a flight will be late. So I can select that when I'm doing my machine learning. And the quarter, when I think about the quarter, well, hey, we live in Canada. So a flight that leaves in winter versus summer versus spring versus fall, I think that could also give us a pattern of which flights are more like, the flights in certain quarters are more likely to be late than flights in other quarters. For example, if you're flying in February, I think it's more likely your flight's going to be late than if you're taking a flight in June. But unfortunately, when we look at the data set, we discover all the data in this data set, there's only one unique value for quarter. It's all from the same quarter. And in fact, if you actually look at the month, you'll actually discover that there's only one unique value in the month column, and it's a value of 10. So all the data we have to do our training is from October of 2011. So that's why it's important to take a few minutes to visualize the data set, get a feel for the data you've got, because this will help you realize what data you do have and what data you don't have. And the better you know the data, the faster you're going to get an accurate model when you do machine learning. So what I've done so far is all I've done is taken a data set and put it onto my page. The next thing we have to do is we have to do what's called pick our projection columns. So there's a task called project columns, and by the way, I am going to give you a URL at the end of this presentation, and that URL is going to take you to a page where you will find a link to step-by-step instructions to completely reproduce everything I'm doing in this demo. So if you get lost at any point along the way, don't panic. There is a nice URL I'm going to give you at the end of it. That one URL is going to give you links to step-by-step instructions so you can reproduce everything that I do here, and even give you some follow-up materials to learn more if you're interested. So back to my demo. Flight on time performance, what I need to do is I need to say, take that data, but I want to tell it that, you know what, there are some of the columns in there that aren't worth using to train our model. They're not going to affect the outputs. For example, we noticed that all the data was from the same year, the same quarter, and the same month. So what I can do with project columns is we say, here's the columns we think are important and will affect if a flight is late or not. Said, year, quarter, month, even though they might have an impact, all my data is from the same month, quarter, and year, so it's not going to help me find patterns in data and predictions. The day of the month, maybe the beginning of the month, the first of the month, you have flights that are more late than end of month. I think day of week is definitely something that might affect whether a flight's later on. I think Monday morning is a very busy time for flights. I think the airport could be a factor. I think if you're flying out of Chicago O'Hare or Pearson Airport, you're more likely to be late out of those ones just because of the volume of traffic than you are if you're flying out of, say, the Winnipeg Airport. So origin and destination airport ID, definitely things I think could be a factor in determining whether a flight's later on time. Departure time. That one is one I want to include as well, because I think there's sort of a rush hour for planes in this sort of, in the early morning, sort of between 7 and 9 a.m. and in the evening between 4 and 7 p.m. There's a lot more flights at that time. So if you're catching a flight at 5 p.m., it's more likely to be late than a flight at 1:30 in the afternoon. Maybe even the scheduled arrival time is a factor as well. And you have to select the column which you're trying to predict. So that, for me, is arrival delay 15. Which will be a 1 if the flight was 15 minutes late, a 0 if it wasn't. So I select the columns. Now, if you're trying this with me, you don't have to pick the same columns I do. It's called an experiment. If we're not happy with the results of our experiment, we might come here and change and pick different columns to try and get better results. All right, let me go back to my slides for a second. So what we've done is we've started with our data. So said there's different places you can get the data. I've used one of the sample data sets that comes with Azure Machine Learning Studio. You can create your own data sets from CSV files, so you can extract data from a database or spreadsheets, save it as a CSV file and import your own. You can also use those reader tasks to get data from a data feeder query. There's also the world of open data out there, which allows you to find all sorts of fun data sets as well. If you just want to find some fun ones to play with, check out Kaggle.com, Kaggle.com. They have some interesting data sets that companies make available for competitions. After you load your data set, take your time to get to know the data set, learn what the different column values are, learn what records you have and don't have, what columns you have, and what data they represent. The better you know your data, the faster you're going to get good results from your training model. Now that we've got our data, we're ready to train the model. So the first thing we have to do is not trust the computer. I never trust computers. Computers are good at coming up with formulas, but how do I know if it's right or not? When I do my model training, what's going to happen is the Azure Machine Learning Studio is going to analyze the data, and it's going to come back and say, Susan, I have found the most magical formula ever that will represent and make all the predictions you could ever want. But how do I know the formula is good? How do I know if the formula is going to predict the accurate values? What I want to do is I'm going to take some of my data and split it up. So I'm going to take some of my data and I'm going to put it aside So let's take 80% of our data, and we're going to use that to find patterns, to create our formula to be able to predict the future. But we're going to take 20% of our data and put it aside. And once the computer says, oh, no, I figured out the magic formula, I'm going to say, you think you got it figured out? All right, let's test it. I'm going to give you 20% of the data, like 100,000 records, for which I know if they were late or not. You run your little formula, predict what you think would have happened, and let's compare that to what actually happened. And then we'll see how well you did making your magic formula. So this is a fairly standard thing in machine learning, the idea of splitting our data up. So we use some of it to test the model and some of it to train the model. Now, when we're creating our magical formula to predict the future, there's different types of formulas that can be created, and we do this with the different algorithms. And which algorithm we use depends on the kind of prediction we're trying to make. If you're trying to predict something like a yes, no, a 1 or a 0, you're trying to predict if somebody who made a purchase was a male or a female. Those are examples of two-class algorithms. So anytime you're trying to predict if something's going to be one of two specific values, we call that a two-class algorithm situation. If you're trying to predict, so you can even be trying to predict if somebody's going to vote Liberal or PC, Republican or Democrat. Those are all examples where you're trying to predict one of two values. Classification is used when we need to predict more than two values. So if you're trying to predict if somebody is going to vote PC or Liberal or NDP, well, now I have three values I can try to possibly have as outcomes. So I would have to use a classification algorithm. If you're trying to predict if somebody's going to vote for Trump or Rubio or Cruz, again, that's three possible outputs. So I would use a classification algorithm. If I want to predict if someone's income is between $50,000 to $100,000, between $100,000 to $250,000, or between $150,000 and $200,000, so which range they fall into, that would be three different possible ranges, or you might have 4 or 5 or 6 different possible ranges, still using a classification algorithm. If you want to predict a specific value, so let's say you wanted to actually predict how many votes someone is going to get, or you wanted to predict how much money somebody makes, or you wanted to predict how many minutes late a flight is going to be, that would be a linear regression type example. So that's used when we're trying to predict a specific value. And the last one, you've probably encountered in your own way, anomaly detection. This is used to find the entries that don't match a pattern. The most common example of this is think of credit card fraud detection. Sometimes when you make a purchase, your credit card company freezes your credit card. So that's an example of anomaly detection. It said, hey, you've done something that doesn't follow your usual pattern, and machine learning says this isn't your normal pattern. We think someone may have stolen your card, so we identify it as an anomaly. So that's also done with machine learning. So anytime you're doing machine learning, you have to think about what type of prediction you're making so you can pick the right type of algorithm. In our case, we're trying to predict if the field arrival delay 15 is a 1, indicating a flight was late, or a 0, indicating the flight was on time. So we're going to use the two-class algorithm. And then once we've got our magical formula, we're going to test it with the data we put aside. So let me show you how we do that in the tool. So we've selected our columns. So now what we're going to do is we're going to take some data and put it aside so we'll have some data for testing once the tool thinks it's found a magic formula. So we connect our data and send it to a split. And then over here on the right, when we select split data, you see there's some properties. And I'm just going to change that fraction of rows to be 0.8. The generally accepted standard is anywhere between 70 to 80% of the data is used to train the model, and 20 to 30% is used for testing. So I've taken it. So because I said 0.8, that means 80% of the data is going to follow down path number 1, and 20% of the data will go down path 2. So it's basically taking my 500,000 records, send 400,000 down this path, and about 100,000 down this path. Just going to get rid of that little extra window. Once I've done that, it's time to train my model. This is when the magic happens. So this is where we actually say, hey, Machine Learning Studio, I want you to actually go off and actually find the patterns. So you take the output, we take that 80% of our data, and the nice thing is if you try and connect it to the wrong button, it actually gives you a red light and says, you can't connect here, connect to the other node. So don't worry about it too much. And then you have to tell it, what's the column you want me to try and predict? So we have to go to the column selector. And we select that field arrival delay 15 because that's the column we want to predict a value for. We want to know if that's going to be a 1 or a 0. Now, we haven't told it what type of analysis to do yet. We don't know if this is linear regression or two-class or classification and so on. So that's why there's this other node here, because this is how we get to tell it which type of formula to do. So if you search for to-class, you'll actually discover that Machine Learning Studio comes with a number of different built-in to-class systems it can use to do the analysis. I'm sure you're sitting there going, how on earth do I know which one to use? A useful tip for you, there is a wonderful little tool out there. And if I go here and I just go Azure Machine Learning Studio cheat sheet, I love the fact they actually call it a cheat sheet. Do a quick search and you will actually find a handy little PDF file which you can download. Here it is. And it's a flow chart that gives you hints, if you're new to machine learning, on what the difference is between these different choices. So this is a handy little cheat sheet if you're new to machine learning. If you take courses in machine learning, then you learn a lot more about the difference between these and when to use the different ones. And you, in fact, when you get into more high level in machine learning, you actually learn to write your own algorithms as well. But hey, a little beyond what we can do in 1 hour. So I'm going to pick the boosted decision tree. If you're trying this with me, feel free to pick a different one just to see if you get different results. It is an experiment after all. If I'm not happy with my results, I can come back here and pick a different one, see if I get better answers. And I'm going to connect that to my train model. Well, if I run this now, after that train model task is done, Machine Learning Studio will say, I've got a formula. I know exactly how to predict the future now. So this is where I say, you may think you have a formula, but I don't trust you. I want to test it. So this is where we use a task called a score model. The score model is basically our testing task. So we say, take that formula you just created in the trained model, take that 20% of the data we put aside here when we split our data, and send those rows down here and say, you test your formula against those rows we put aside, and let's see how well you predict against records where we know what happened. Then we just have to say, put that result into a nice, pretty report so a human can understand the result. So we take the score model output and we send that to evaluate model, and that simply puts the data into a report for us, and then we hit run. I have now created a machine learning model. Now this is going to take a couple of minutes to run. As it's running, I'm going to see little clocks appearing on the tasks. The trained model will take the longest, and because that's where it's actually trying to figure out what is a formula to analyze the data. And then the score model will take a little while to execute as well, because that's the step where it's actually doing testing against 100,000 rows. But while that's running, I want us to think about, what do we do if after we go through this experiment and we get the accuracy, what if we get lousy accuracy? What can we do to fix it? And if you've got ideas, feel free to toss them into the QA window. And give you a second to see if anybody wants to throw a suggestion out there. I can start humming I can always start humming the Jeopardy theme song if you want. Where do you set input parameters? Well, there are some input parameters that you can specify for the different algorithms themselves. So some of the algorithms have parameters. So you would do that by selecting the algorithm on the tool, and then there's a parameter thing that appears on the right. But I'm not sure what you mean by input parameters. I mean, the input data is specified by the data set that we select. And the project columns is where we select which specific columns from the data set we want to use. So some of the things you can do to improve accuracy, well, you can have more rows of data. Right now, all my data is only from October of 2011. What if I had data from 2012 and 2013 and 2014? What if I had data for October, December, January, February, March, throughout an entire year? What if I had data from Canadian Airlines as well as American Airlines? The more data you have, the more rows you have, the better the machine learning tool can find accurate patterns to predict what causes and what are the causes of late flights and predict what future flights will be late. Sometimes there might be other data sets that you can join to it. What do you guys think is the #1 cause of flights being late? When have you been stranded in the airport and why were you stranded? Yes, weather, exactly. The weather is a big factor. Well, if you go to the world of open data, you can access weather data sets. So you could bring in a weather data set and join it to your flight data and actually identify the patterns of the flights that left on snowy days were more delayed than the flights that left on sunny days, or maybe there's certain weather conditions in Vancouver that cause fog, so that increases flight delays and so on. So you can bring in multiple data sets and join them together. It's kind of like joining two database tables, like doing a join clause between two SQL database tables. It's very similar. You just bring in the two data sets and you identify how do I match records from data set 1 to data set 2. So that's a great tool for really improving your accuracy. Sometimes you might want more columns of data. There might be other information we could find about individual flights that would give us more information. For example, what if you knew the duration of the flight? What if you knew what type of plane was being used? Maybe Dash 8s arrive on time more often than new Dreamliners, or vice versa. Maybe flights going east to west arrive late more often than flights going west to east, because in Canada, when we go east to west, we usually have a headwind, and when you go west to east, it's usually a tailwind. So there's other columns of data we might be able to create, find, or calculate that could possibly help us get a more accurate prediction as well. So again, it comes down to the better you understand the business problem you're trying to solve and the data, the more accurate a model you're going to be able to create. So if you understand what actually causes flights to be late and on time, you're going to be better at bringing in the right data so machine learning can do an even better job. Cleaner data can be a factor as well. Whenever you've got missing data, that can cause problems. One of the most common situations is, you get a 0 value for something. There's another example I sometimes do where I try to write a machine learning algorithm to predict how many miles per gallon a car will run on, what its mileage is going to be. Well, one of the factors it looks at is the weight of a car. Imagine if you had a car and you didn't know its weight, so they just entered a weight of 0. Well, if you tell machine learning to go analyze these records, it'll say, hey, look, all the cars with a weight of 0 had this miles per gallon, or got this many miles per gallon. That's not accurate. There aren't any cars that are actually 0 kilograms. So having a 0 value for missing values can kind of mess things up. So cleaning up missing and incorrect values can help. Another scenario might be, let's say you had a province code of ON for Ontario, but another system had a value of ONT for the province. Well, machine learning is not smart enough to know that ONT and ON are the same province. So it's then going to say, hey, the flights in ON had this pattern, the flights in ONT had this pattern. If you clean up the data first to make sure that all the province codes are consistent, then machine learning understands all those records are actually from one province, and that will also influence your output. So the cleaner your data, the better. In fact, I would say that you probably want to spend 80% of your time getting the data cleaned up, joined together, and then only 20% of your time mucking around with the machine learning tool. Different algorithms. You saw there were 6 or 7 different 2-class algorithms that I can use. Maybe I should have picked a different one. And there's different algorithm parameters. So when I'm actually in the tool and you select 2-class boosted decision tree, on the right-hand side here, you'll see there's a bunch of parameters and things you can change. I'm not going to explain what all these do. If you're curious, you can click on the help button here. It'll actually bring up a page that actually explains what all those different parameters are for. This is getting into a little more advanced machine learning. But basically think of it as these allow the formula to do a deeper analysis before it develops its formula. So typically it will cause the machine learning to take longer to run, but it may give you a more accurate result when it's finished. Now I actually have green check marks everywhere, so my model is done. So I can actually now go to Evaluate Model, and I can right-click this and say Evaluation Results, Visualize. So we can now find out the formula, the model that was created, is it any good? So if I pick Visualize, I'm going to see a little chart. Now on the chart, the closer you have to a straight line going across, the more your model is just guessing. It has no clue at all. This one's not bad. I've actually got a reasonable curve here. The closer this curve is to the top left corner, the better your model. So there might be, it's not bad, but maybe there's some things. Maybe I want to go add some additional columns or change a couple of parameters or try a different algorithm to get better results. The graph gives you a quick idea. What I really like to look at is to scroll down here and look at what we have is the accuracy. So you'll notice here I have an accuracy of 87.3%, 0.873. So it's predicting with 87.3% accuracy whether flights will be late or on time. And I also like looking at these fields here, true positive, false negative, and true negative. What do these tell me? Well, a positive value means it predicted a 1. So a true positive means how many times did it correctly predict a positive value, which in English means, from our model, means how many times did it correctly predict a flight would be late? 1,600 times. That's not bad. How many times did it predict a true negative? So how many times did it correctly predict a flight would be on time? 85,000 times. Not bad at all. Then you have false positives. That is, how many times did it predict a flight would be late when in fact it was on time? Or false negative, how many times did it predict a flight would be on time when in fact it was late? So this gives you a more complete picture of what's actually happening with your model. So I'm happy with this accuracy. Maybe I'd make some changes. But I also want to show you, once you've created the model, how do you use it? I mean, it's really nice to have this pretty graph, but you know, once you've trained a model, how do I, could I sell this to Expedia or to Air Canada so that when people are booking flights from their website, they can get information to tell them, hey, this flight's more likely to be late than the other one, so you might want to take the flight through Calgary instead of the flight through Chicago? That might be really useful. I might be able to make money on that. So to do that, I have to deploy this as a web service. And at the bottom right on my toolbar, there is the option to set up a web service. Now, if you are following along with the guest login, you won't be able to set up the web service. The URL I will give you afterwards will show you how you can set up free trials to explore and try the whole web service as well. But the guest sign-in, because it's a guest sign-in, doesn't allow you to do the web service part. So you won't be able to do this part of the demo with me. But I'm going to give you a link that'll show you how you can try it yourself later. But I still want to show you how it's done so you know. So I set up a web service, and I say create a predictive web service. And what it's actually going to do is it's going to take the experiment I have here, and it's going to make a copy of it. So I'll actually have 2 copies of the experiment, the training experiment, which is one I was just working on, and a predictive experiment. It's the predictive experiment that controls my web service. So this is going to be my predict the future web service. I'm using someone else's keyboard. I can only find backspace. I can't find the delete key. All right. So I'm giving it a name, and you'll notice that it's got there's the input to my web service. So this defines the data that we passed into my web service, and here's my web service output. So here's where the data gets passed back out. I am going to make one change. By default, it connects the web service input to the projection columns. That means it expects me when I call the web service to pass in a value for every single column in the data set. But I know that some of those columns aren't helpful. So what I might want to do is I'm just going to redraw that to the score model task, because that way I only have to pass in, I'll only have to pass in the columns which I said were important, the ones I selected in my projection columns task. So it just makes it easier to call my web service. Then I run it. Running this effectively is compiling my web service. That's all it's really doing. And it doesn't take too long because it already has the formula. So really it's just compiling some code here. Chugga, chugga, chug. There we go. And once it's compiled the code, then I can deploy the web service. So down in the toolbar, it now gives me the option to deploy. And over here on the left, there's a machine learning experiments toolbar, and there is the web services. So as soon as it's created the web service, it's going to hop me into this web services dashboard. So you'll notice it's now changed this to the active dashboard. And I can see the information for my web service that's created. And there's 2 ways to call the web service. You can call it passing it 1 record at a time using request response, or you can pass it multiple records at a time using the batch execution. There's even a nice little test option here you can use to sort of test how would it work if I called the web service. So I can say, let's say I was leaving on the 25th of the month, and I was leaving on a Monday, and the originating airport, and sorry, I didn't memorize any airport IDs, 5566. I know they're 5 digits, but I don't know the actual codes. And I had a departure time of 14:23 and an arrival time of 17:15. So I'm leaving at, let's say, 2:20 in the afternoon, and I'm arriving at 3:15. And you leave the value you're trying to predict as 0. Don't pass in the null, otherwise it always returns nulls. And when you click the OK button, Down at the bottom, you can see it's calling the web service, and it's actually saying, here's the record that got passed back. And if you bring up the details, it'll actually tell you, here's all the record values you passed in, arrival delay, and at the end of the record that passes back, it passes you back scored labels and scored probabilities. Those are the magic fields. Scored label is what's the value it predicts will be returned for the specified flight you created. So is it predicting the flight I listed will be later on time? And scored probability is the value or the accuracy or the confidence with which it's making that prediction. So you can see it predicted a 0 here for score label. That means it's predicted my flight will be on time. 0 is on time. 1 means it's late. And it predicted that with only 10% confidence. That's probably because I entered invalid airport IDs. Those weren't real IDs. So you can play around with that to get a feel for how it works. Once you feel that you're happy with your web service, the other thing you can do that's handy is if you actually click on the pages for batch execution or request response. So if I click on that, it'll actually bring me up a page where it shows me if you wanted to call this with an HTTP post. Here's an example of a call to do that, and the header values that you pass in. And even better, if you click on sample code, it'll actually give you a snippet of C# code that actually calls the service for you. All you need to do is change the values you pass in. And the API key here, you need to change that to the API key that was back here on my machine learning web page, this key here. So I have to change with that API key to give people permission to call my service. And you notice I can get sample code in C# or Python or R. So this is specifically generated for my web service. Wonderful little advantage there. All right. So that effectively at this point, I have executed an experiment. I have deployed it as a web service, and I've even got sample code to call that web service. So I can call this from a phone app. I can call this from a website, depending on what I want to do. So we've sort of talked about how to create the web service now. I did want to share, if you want to play with somebody else's created web services, there's a neat project out there called Project Oxford. There's some fun APIs you may want to go play with. Those were all built using machine learning. So those are examples of web services that someone else has created. Somebody at Microsoft went and created these, and they allow you to call these web services. And some people actually do this as a business model. These are the fun ones. You may have actually heard of some of them. There's an emotion API. I'll run one of them just because it's sort of, actually, I won't have any images, so it'll be hard to experiment. I'm not on my computer. But if you go to Project Oxford, it's a fun little website to play with. And, you know, you can load your own pictures and see what happens. This is the one, if you saw any tweets or people talking about these ones that predicted what your age was and whether you were happy or sad and so on, those all come from Project Oxford. So you can do some fun things like emotion recognition. It's one of my favorites to play with. And you pass it in different pictures, and it looks at the picture and analyzes, you know, this person they think is mostly happy, a little bit of disgust. This person is very happy. This person here, if we analyze that picture, you know, you can see they come up as mostly anger and disgust, not so happy at all. You can upload your own pictures by clicking Open Image as well and play around with this. So there's a whole bunch of really cool APIs here. These are all built with machine learning. Now, these are more complicated ones because they're based on images, but it's an example of how once you've created an API, you allow other people to access it. If you want to play with these specific ones, just to show you the pricing, generally for just playing around with, you can do most of them for free. It's only if you get up to pretty high numbers of transactions, you'd actually get charged. So a lot of these you can do for free, see multiple transactions per month. So they're a lot of fun to play with. All right. Now, I'm going to leave it open for questions now, but I did want to leave you with this one URL, ak.ms/ML workshop. And that URL, and I'll bring it up here so you can see it, that is a URL to help you try what you saw here. Here's the step-by-step tutorial on how to create your first machine learning experiment and deploy it as a web service. Here's some other examples you can go exploring. This gives you some tips on different ways to get access to the full version of Azure Machine Learning Studio, depending on your scenario. If you're at a company and they have an MSDN subscription, you may get some Azure for free through that. Anybody can get free trials. You can explore the guest sign-in in Azure ML Studio, so all sorts of tips on different ways to access the tool. If you want to learn more about machine learning, here's some suggested other courses. Because I am doing this at a training center, I will also mention that probably the most useful course you can sign up for would be something on integration services, SSIS, SQL Server Integration Services, because that will teach you a useful tool for manipulating your data so that it will be set up the way you need it to run your experiment. So it allows you to create calculated fields, join data sets, and things like that. So I would recommend, if you really want to get into machine learning, a good complementary tool would be to learn integration services. And at this point, I am opening it up to questions, but thank you very much for being so patient as we were getting set up.